Okay, hey guys, today we're going to deal with the topic of composite functions, and this is the last topic really for functions, and this would basically conclude the entire topic of functions. Okay, for composite functions, firstly we're going to have two functions, and we can let them be f of x and g of x. Now, I said before that functions are denoted by f of x, but they can actually be denoted by g of x or h of x sometimes, right? F, g, and h are the most common ones you'll see. Okay, so for a composite function, it is denoted by f of g of x, and we have two notations to it. You can either write it like this, or you can write it like this. Okay, and the domain of f of x for a composite function becomes the range of g of x. Okay, note that f g of x is not equal to g f of x. It is not commutative. In some cases, you might find that f g of x might be equal to g f of x, but that is not always the case. Okay, so yeah, and one last thing, basically composite functions, what it basically does, it combines two functions together as one. Okay, um and if we, when finding composite functions, okay, um if we multiply a function by its inverse, okay, um you will get x as the result, okay, which we will see in an example here. Okay, well, so we have a question here, and the best way to do composite function is through questions. Okay, so we say let f of x be equal to 5x and let g of x be equal to x squared. We're going to find g f of x. Okay, now don't overthink this. Okay, to find g f of x, really simple thing we have to do. So we say g and f of x. Okay, and f of x is 5x. Okay, so we want to find g of 5x. So remember how we said for a function f of x, wherever you have x here, now what we're going to do is we're going to replace x by 5x in the function g. Okay, so you see what we're going to do here now. So we want to find g of 5x, which would basically be g of x is equal to x squared. So we're going to look for the value x, and wherever we see x, we're going to replace it by 5x. Okay, so this would therefore be equal to 5x all squared. Okay, remember it is the entire x being squared. A common mistake is to have 5x squared and see that is gf of x. Okay, but that is wrong. Okay, and this would be equal here to 25x squared. So this is gf of x. Okay, now we want to find fg of x. So again, same thing we do. We have f open brackets, and we want to put g of x now. So g of x is x squared. All we're going to do now is in the function f of x, wherever we see the value x, we're going to replace it by x squared. Okay, so this would be equal to 5x squared, and this is the value of f g of x. Okay, it's as simple as that. Okay, f squared of x now. Okay, basically what this means here, this is equivalent of f of x. Okay, so f of x, so we basically take f, and then we have replace f of x now here by 5x, so we have 5x. So now all we're going to do is wherever we see the value x in f of x, we're going to replace it with 5x. So this would be equal to 5 multiplied by 5x, which is equal to 25x. Okay, and now if I want to find f squared of 1, we already have the value of f of x, right? So all we do here now is substitute the value 1. So this would be equal to 25 multiplied by 1, which is equal to 25. Okay, and it's pretty much as simple as that. Okay, guys. So let's say I have the function 3x plus 1. Okay, say f of x is equal to 3x plus 1. I want to find the inverse. From our first step, let y equal to 3x plus 1, interchange x and y, and then make y the subject. So we'll have x minus 1 is equal to 3y. Therefore, we have y is equal to x minus 1 divided by 3. Therefore, the f inverse of x is equal to x minus 1 over 3. So what we're going to do now is find f multiplied by the f inverse of x. So we're going to find f inverse of x. Okay, this would therefore be equal to f, and we open any brackets and we put in f inverse of x. F inverse of x is x minus 1 all over 3. Okay, now in f of x, wherever we see x, we're going to replace it by x minus 1 over 3. So we're going to get 3 multiplied by x minus 1 over 3 plus 1, which is equal to x minus 1 plus 1, which is equal to x. Okay, so notice here now, whenever you find f multiplied by f inverse of x, or f inverse multiplied by f of x, we will always get back x. Okay, and that's pretty much it for functions. Again, remember, functions can be denoted by f of x, g of x, or less commonly h of x. It is not commutative, so f of g of x is not equal to g of f of x. Okay, and again, f inverse of x is equal to the f inverse of f of x, which is equal to x. So let's say I have a function f of x, and I want to find if I find that f g of x is equal to x. What this tells me is that g of x is the inverse of f of x. And that's a common question. What they would do is to give you a function and tell it to find fg of x. And if the result equals to x, they would ask you, what does this mean? And this means that g of x is the inverse of f of x. And that's really it for the topic of composite functions. It isn't really complicated, pretty short. And that was the end to the topic of functions. Okay, so again, remember the topic of functions. We covered domain, range, codomain, the inverse of a function, how to find the inverse of a function, and we also covered injective functions, which is one-to-one functions, and this last topic here was composite functions. And that's it for the topic of functions. Okay, thank you for watching, and I hope you learned something.